Hi everybody, it's Greg Roark, Director of STEM Education at Redbird Flight Simulations, and today I want to visit with you about something we've talked about before, which is the visualization exercises that you can do in your classrooms. Now, I don't think I need to tell anybody what a big champion I am for using simulation integrated into your aeronautics programming, but sometimes you are not able to get your students in front of the simulators the way that you'd like. In fact, sometimes you can't even get them into your classroom the way that you'd like. So what do? You have some conceptual information that you know is important for students to understand, and visually that can be a big impact for them. So what do? Well, what you can do is you can put visualization pieces on a piece of paper or on a computer screen, but my experience has been that when you do that, it does not have the impact as it does if you go bigger. And I think that you all know that down here in Texas, yeah, we do. So with that, what I want to do is I want to show you some of those visualization examples that I've used in the past, and I want you to see sort of what they look like from a student point of view. So with that, let's take a look at a couple. Now in this visualization exercise, it's one of the ones that actually got me started working with students with mapping stuff out on the floor. And the reason I did that was primarily because of the surprise of young people and their absolute lack of awareness of direction. And it just blew my little mind. Again, I've been working with young people for 12 years, and this is still an area where students, if they have not gotten involved in any programming that I've run at an earlier age, they get to high school and they may not know this. So it's one way to actually start them thinking in terms of these things that we really want them to know. You think, okay, how do you get from one place to another in an airplane? Well, you follow ATC directions. Well, that's kind of part of it. But if ATC tells you 504 Hotel Lima, turn left heading 090, well, if you don't know what 090 means, you may just accept anything, and that may not be the direction that you really wanted to go. So we had to learn direction. And then with that, we learned that with the compass rose, that there's a corresponding heading, a 3-digit number. So remember, direction is a word. Heading is a 3-digit number. And so with that, I want you to take a look at what I've got here in the floor and just one of the ways that I teach this. So here I have drawn out in the floor, I've drawn out something that looks an awful lot like Class Charlie airspace, for those of you that are familiar with that. But I can also at the same time, I can put the tick marks for the primary or cardinal, secondary, and tertiary directions and the corresponding headings in this. Now, for the sake of what we're doing here, let's assume that we're going to go with a north-up orientation. Now, in your classroom, what I would recommend is, first of all, I'd say, okay, class, point north, and then watch what happens. It's usually pretty entertaining. But with that, if I were doing this inside in a classroom area, I would try to set it as close to magnetic north as I could, so that when students walk in the room, they sort of have an understanding about the orientation of north, south, east, and west, at least the cardinal or the primaries. But for the purposes of this exercise, let's go ahead and pretend that we're doing this here with a north-up orientation. So with that, this tick mark that I have here at the top of my circle is going to be north, okay? Now, I've done this a couple different ways. One is that I've had students do this with sidewalk chalk, just like I've done it here, and I've had them actually write in the letters and the numbers for the direction and the heading. But then I actually had a student who made some flashcards. I know, old school, flashcards, right? But it got me thinking, this is probably a better way to do it, and let me show you how. So on some note cards, what you can do is that you can ask students to put the letter for a particular direction. Remember, direction is a word. And you can also have a card here for that corresponding heading. So, for instance, if we look at this north, and if we're looking at the example that we have in the floor of assuming that we're going to go with a north-up orientation like we talked about before, this may be the first one that you want to place just for orientation as you start the exercise. Down the road, you may want to start with south-southwest and then have the students figure it out from there. But to start, this is how we begin this here with these cards. And now let me show you on the floor how we can use those. So I'm going to take the cards that you just saw here, north here, and then again its corresponding heading here, and I'm going to place them in the floor. The way I like to place them is this. I want the direction on the inside, and I want the corresponding heading, I want that to be on the outside. And there's a reason for that. The reason that I put them in that particular orientation is this. When you're looking at a heading indicator, and you're looking at, let's say, a G1000, on top of your HSI, you've got a little box. That's where you're going to see that heading, correct? And then you see inside of that, you'll see letter representation of the direction, right? So I like to lay it out in the same way that students are going to see it on the simulators when they can get back to the simulators. So we take north, tree 60, we take that as our reference, and then we can place the rest of the cards. So with that, we will place the primary or cardinal directions and their corresponding headings. Next on this is going to be east, right? So we'll place east over here. And you'll notice also how I'm setting this up. We're going to go with south, and I'm putting it in such a way that the student can read the letter and the number from inside this circle. And there's a reason for that. So here's this. Here is just one of those, should be sufficient. Here's west, and here is 270. Okay, so now I have my primary or cardinal directions with the corresponding 3-digit headings here, right? They're in black. They're all in one color, okay? Next, I have the students place the secondary directions and their corresponding headings. So we start with northeast. Here's northeast. And then we look at this, and I make sure that students understand what that corresponding heading is going to be. Because if north is going to be tree 60, or they can think of it as 0, and east is 0, 9, or 0, what's half of 90? Well, half of 90 should be 45. So the corresponding heading in half that distance should be 0, 4, 5, right? So with that, between each of our primary or cardinal directions and headings, those gaps between there are all going to be in multiples of 45, okay? So, there we go there. Next is going to be southeast. Southeast, 1, 3, 5. Southwest, 2, 2, 5. And we have northwest. Northwest, tree 1, 5. Okay? You'll notice that these are in different colors. I put these in red. You can put whatever color you want, but I do put the cardinals in one color, secondary in another, and then I put the tertiary in yet another one. Because in this case, most students may look at this and they think, okay, we're done. Well, not so fast. So with that, then come the tertiaries. Those are going to be the differences between your primaries and your secondaries. So, when we say north, south, east, west, what are the two we say first? North, south. So those are the most important of what we talk about, right? East, west. So the actual naming here, the nomenclature, comes from saying what's most important first, followed by what's next important. So in this case, the difference between N and E, N, north, that has to be first, followed by east. Northeast, right? So that's the naming convention that we use when we're looking at naming the directions, okay? So It would then follow the same rules if we have north and northeast. We've said north is most important, right? So we would say north first, followed by northeast. So that would make that gap between north and northeast, you got it, north, northeast. So with that, we're going to put NNE right there. I used green. I used green primarily because I had green. So now then we look then at what is going to be the corresponding heading of north, northeast. So when we got to our secondary, we were looking at the difference between 0 and 90, half of that, 45, right? So we look at that, same rules, 0 to 45, what's half of 45? 22.5, 22 and a half. Can you fly half a degree? Well, not on purpose. So we have to give it a degree, right? So what do? Do we round down or do we round up? I have asked 100 people about this, and every single 100 person will tell me something different. I've also used a dozen different electronic compasses, and they're all different about when they switch and click over into that north, northeast. So do you round down or do you round up? Here's what I do. I alternate. I round down on the first one, I round up on the next one. The reason I round down and round up is because I want students to think about that particular number, about that 22.5, and just keep thinking in terms of where that falls in that sequence, to get them thinking in terms of that particular direction and that corresponding heading. So with this one, we have 0 to 2.5. Well, we're going to round down, so it's going to be 0 to 2. And there it is. So for the next one, the name of this next one, we have east, northeast. We know that east trumps northeast. So with that, we'll say east first, followed by northeast, east, northeast, right? So there's that one. We lay that on the floor. Now we're going to round down. So remember, we're working with 22, then 23, 22, 23, 22, 23, all the way around. So if you're here, you're adding 22 to 0, that's going to give you 22. But if you add 23 to 45, remember you alternate, what does that give you? 45 plus 23, 0, 6, 8, right? That's what we're going to have here in east, northeast. Now all you do is you follow that same rule all the way around your compass rose. East, southeast, 112. South, southeast, 158. South, southwest, 202. West, southwest, 248. Who do we appreciate? Mr. R, Mr. R. Okay, stop. So there's that. West, northwest, 292. And last but not least, north, northwest, tree 8. Tree 8. Notice the way I say it. Say it like the FAR AIM asks us to say these numbers. So that's the way we do it, to follow this rule. So with that now, as you can see here, spaced out here on the floor, is that I have all of the primary, secondary, and tertiary directions and their corresponding headings. When we look at this, the reason that I'm in this circle, and you'll notice that X marks the spot, if I'm in this circle and I turn any one way and I look in this direction around my compass rose, I can always read what my direction and its corresponding heading is. So here's a way that I show my students how to think of this, especially when it comes into the form of runways, how they're numbered. Okay? Take a look at this. So what I use here is I'll use just a yardstick or a meter stick. In this case, I've gone old school with a yard stick. And what I'll do is I'll say, okay, if you're facing, let's say I'm facing the direction of west, but I'm on an airport runway, what number do I expect to see on this runway as I taxi out from the taxiway onto the runway if I want to take off headed to the west? Well, if I do that, then here again, I lay the meter stick or the yardstick out there like this. So then that way the student can look at that as a representation of the runway and to say, okay, remember the rules about, how we number the runways magnetically and lop off that last digit. So in this case, I want to see 2-7 right here at the piano keys. I want to see 2-7 there. I want to see 2-7 on my HSI. I want to see 2-7 here on my wet compass. And so I use that meter stick there sort of as that representation. So they understand here again that directional importance of this compass rose. So with this, I wouldn't necessarily go out myself and just place all of these cards. What I would do is to each group of students who would be responsible for running their own compass rose lab that they're doing, which is drawing the circles and then being able to put the right tick marks along that compass rose and then to be able to label them, I would have them do it. Then, as a little test, here's what I would do. I want one person in the group to collect all the cards, okay? Collect all the cards. Then what I would do is I'd go up to each group and I would randomly select 5 or 6 of these cards and say, put them where they're supposed to go. So then that way they're not going to have the benefit of seeing all of the other directions and those corresponding headings. They actually have to count. They have to look at that and make sure that it lines up. So with that, that's another drill that they can use with this, the compass rose. Because remember, you want these students to have these directions and their corresponding headings engraved in their brains with letters and numerals of fire. Because again, there can be no hesitation when ATC says turn left heading 270 as to what ATC's intentions are for you with regard to direction. So that's very important. Hopefully this has made sense to you or even perhaps given you better ideas than what I had. Now, in this particular floor exercise, what I wanted to show you was airspace. Airspace, again, is one of those conceptual elements that oftentimes students have no relationship to what airspace may be, unless, of course, they've been playing three-dimensional chess or something along those lines. So with this, one of the things that I found is that there's a big difference between actually moving through airspace physically than it is to necessarily be looking at a computer or looking at a flat paper image of airspace. And it's one of the reasons why I like to get students actively moving and working on airspace in this type of a format. So let's take a look here at what some Class Charlie airspace may look like when it's drawn on the floor. So here's an example of Class Charlie airspace when you're looking at it sort of in that plan view element here. In this particular case, I chose Austin Bergstrom International KAUS. That's what I chose here. In the center, you can see in this the center cylinder here, which again, you're looking here at a radius of 5 miles, the diameter of 10 miles here. And then you have that outer shelf that you normally find in Class Charlie airspace. In this case, it's a nice circle here. And we're looking at this here, a radius of 10 miles and a diameter of 20. Now this is to scale here. Well, it's not to like scale, but it is so that they can see what the difference is here between this inner cylinder and the outer shelf. Also, I have taped in the floor the runways, like the runway configuration that you would see if you looked at a sectional map of KAUS. Also, I've drawn here in the floor, I've drawn the altitude parameters of what this is. You remember Class Charlie airspace. Normally you're looking at airspace that's going to top out about 4,000 feet AGL with this. The Austin Bergstrom International Airport's about 500 feet MSL, so that kind of makes sense here. So you can see that I've drawn 45 over the bar of surface. So from the surface to 4,500 feet MSL, that's this inner portion. Then again, the outer shelf that I've labeled here, 4,500 feet MSL is going to be the top, and 2,100 feet MSL is going to be the lower portion of that shelf. So what that means is that if you're looking at that as 2,100 feet MSL, you've got roughly about 500 feet MSL is what you have the actual surface level here of Austin to be. So with that, you're looking at about 1,600 feet to play with underneath this bottom portion of this shelf, underneath Class Charlie airspace here again. So with this, this is what this Class Charlie airspace can look like. Now, in just the sake of time, I did not go and draw Class Bravo airspace with this, with other busier airports, but it is something that I do recommend when you have at your home airfield, and you may be under the shelf of some Class Bravo airspace. This may look very, very different here based on your home airport. You may have some Class Delta airspace underneath one of these shelves over here as well. And in fact, being able to outline where your Class Echo airspace, the boundaries there as well. So it really helps students to be able to sit here and be able to draw this out in a plan view, but it seems to help them more when you lay it out in a profile view. And with that, let's take a look and see what that looks like. And here it is. What happened to all that airspace? Well, that's a great question. And this is one of the things that always surprises students when they actually lay something like this out in a profile view as opposed to a plan view. You look at that Class Charlie airspace in a plan view and it looks like it's going to be huge. Well, it kind of is when you look at it from up above, but when you're looking at it from the ground, it's not very high. In fact, even for me to make this drawing make sense for you, I actually had to double the scale to make it work for you. So understand that what you're looking at right here is actually twice as high as it normally would look if you drew it to scale. Because if you can see here, and I kind of left the boundaries here of this Class Charlie airspace here for you just to kind of compare. So this inner cylinder here, you can still see the shadowy outline of what that looks like. Now remember that the diameter of that is 10 nautical miles. So I used the scale of 1 inch equals 1,000 feet. So with that, 6 inches is going to give you a statute mile. So if you think about that, here's 60,000 feet across here, but now when you look here to see what this paltry 4,000 feet looks like compared to it, it just almost looks like a flat line on the floor. And students are often surprised about that. And it's one of the reasons why I really like to draw this out. Now, if you have a lot of room and you can use a different scale with that, then of course this is going to look different. But you better plan on having a lot of room if you're going to do that, especially if you're going to be looking at something like Class Bravo airspace in some of the more complicated Class Bravo airspaces, if you want to do it to scale. But that's why this looks the way that this looks. Now, the things that I want my students to know when they're looking at this type of Class Charlie airspace, I want them as they're kind of maneuvering an airplane around that's taped to the end of a yardstick, as they're moving it around. What type of equipment do I need on my airplane in order to be able to fly in this kind of airspace? What kind of permission do I need? How do I know that I have been approved to actually fly in this airspace? Or if I choose not to fly in this airspace, what are my rules here as when we're talking about underneath the outer shelf here, as opposed to what are the rules as I fly across the top? So I want them to be able to tell me that as I ask them questions. I may push that yardstick around with the airplane on it and say, okay, here I come, what needs to happen? And then I want them to be able to tell me all about the communications that need to occur in order for someone to actually penetrate this Class Charlie airspace, or Class Delta airspace, or Bravo, or even if you want to get like a lot of room up there, Class Alpha airspace. So with that, that's one of the big reasons that I like to put these things out there on the floor so that they can get a true idea how that looks when you're looking at it here, not just in a plan view, but also the profile view. Hope this was helpful. Okay, this exercise now that I want to show you laid out here on the floor is a little bit different. This can be somewhat complex, and when you're doing this with your students, I would recommend groups of students doing these airports, because what we're going to do is we're going to lay an airport out here on the floor. When we talk about airport operations and we talk about all of the hazards therein, this is a great exercise for kids to walk through, to learn, and to actually think differently about than they might if they were just looking at this on a computer or maybe on a piece of paper and tracing it with a pencil. It's a little bit different when they're walking it. So, let's take a look. And here we are. Anybody have any ideas where we are? I'll give you a little hint. Aloha. That's right. Honolulu, Hawaii, on the island of Oahu. This is PHNL, Papa Hotel November Lima, or the Daniel Ken Inoue Airport in Hawaii. And what we have done here is we have laid out the airport here. You can see the white tape that we have in the floor here. These are the runways. The blue tape that we have here are the taxiways. Now, I'm going to make a little confession here. I did not lay this out necessarily to scale, nor did I put all of the taxiways on here. I did this just as an example of what you can do. When you have students put these together, I recommend as much detail as they possibly can, including laying it out to scale. And if you do have multiple runways, for instance, as you look at our runways here, you've got our parallel runways here. We have 2-6 left, we have 8 right here. Parallel runways, and you see that we also have 2 other runways that are laying in here at an angle. What angle is that? Well, that's a great exercise for students to solve. In this case, we're about 37 degrees off 2-6 here as we lay out 2-2 left and 2-2 right. So, just saying. Now, let's take a look at what we can do with this particular setup. One of the things that I like to do with students is I like for them to lay the runways out, lay the taxiways out, but not necessarily actually draw the taxiways or to draw the runway markings on them. What I like to have them do, I like to have them create cards. So for instance, if you see this here on a taxiway and you see this particular sign, what is it that you want a student to know about what they're looking at? So when we look at something like this, I like for them to label them. In fact, I may ask them, here, take this card, where would you put it? Now, of course, depending upon the intersections, it could go in several places. But these are the things that you want your kids to understand. Let's take a look at a couple others. So we, of course, have the runway markings here. What about these taxiway markings? Take a look at this one here for just a second. Do you think this one might be just a little complex here on an airport? Yeah, it may be. And I'll show you where this one goes in a minute. So here's an example of another one. Let's take a look at this. Where would this go? Well, if you look here at a displaced threshold, you would want your students to know where these displaced thresholds are here laid out on from the taxiways onto the runways. What about something like this? Well, again, where are you? What taxiway are you on? A taxiway indicator? Not a bad thing to know. What about something like this with these chevrons? So, the blast pads or the overruns. Blast pads or overruns, where do those go? So they can look at those on a satellite image to actually see it themselves with this, or there are several other ways of things that you can show them where they can look up this information. But I like to have them make these cards, and I'll tell them what cards I want them to make, and then I like for them to go out and place them where they really are. So, that's a pretty cool little exercise. With that, let's take a look at these. So as we stand here in roughly the center of the airfield, we'll take a look and we'll see what type of runways that we have, how they're oriented. We can take a look at the width of the runways. For instance, when the students are pulling up those satellite views of an airport, do you know if they know that you can tell how wide a runway are by how many piano keys that there are at the end of that runway? So if we look at this and they look at runway 8 right and you say this is a 200-foot wide runway, how many of those piano keys would you expect to see on the threshold? 16? Yeah, for a 200-foot runway, there you go. What about on these? These are all 150-foot runways. 12. So they can tell the width of the runway by how many of those piano keys are on there. And these are the things that I like for them to actually even draw on the runways themselves so that they can get a feel for how this works. Now, here's another thing to look at here. If we take a look here at where 2-6 right and where 2-2 left and 2-2 right, where they converge, what could possibly happen here? Well, when you look at an airport diagram, would you expect to see some hot spots perhaps around this area here? Yep, I would think so. And I would ask my students why they think that some of these areas through here might be designated as hot spots. Why do you think that is? When you have when you have a runway indicator here, about a directional indicator here for runways that looks something like this, it's like, okay, where does that bad boy go? Well, it actually goes right here. And the student would be looking at this here on this portion that I sort of taped out. So it does get a little busy. And so that's the thing that they need to know. Now, a couple other things. When you have runways here, do you think that there might be land and hold short operations or lasso operations here with these runways when you've got an intersection here like this of 2-6 right? Yes, you probably would. Where would those markings be on this runway? Who can participate in lasso operations? These would be the questions that I would ask them. So not only are they getting airport orientation of their home airport or an airport that they may have an interest in, but they're also learning some of the FARs along with this as you walk them through. You can do this with flashcards. You can have other types of indicators where I've seen some of the students that have used flip charts to say, find this, and it's sort of like, a scavenger hunt for information here as well, depending upon how detailed the students have actually made these airports. And I've seen some kids that have done some pretty amazing jobs of laying these things out, and it's pretty awesome actually. So with that, if you take a look here at all of the different runways as well as the taxiways, here's another thing that I like to have students do. So when you're taxiing an airplane in a controlled space and you get taxi instructions, then to be able to practice those, that's a pretty good thing, right? We can do it on our sims, but again, remember the reason that I'm showing you these is for those times that you may not be able to get a student on a sim. But let's say that you're acting as, in this case, Honolulu ground, and you give your student taxi instructions. What would that look like? Here's how you could have students actually practice walking these taxi instructions. Let's say, for instance, that you're here at PHNL and you're kind of in that general aviation area here. So you're standing over here in the tarmac, which again, guys, I did not tape that part out here. But you're standing over here, and let's say that ground says something to you with the effect of November 123 Romeo Bravo, taxi 26 left, via Charlie, Romeo Tango, Romeo Alpha, hold short 26 left, Romeo Alpha. Okay, let's say that they did that. That's the instruction that you gave them. Well, I use meter sticks. Remember the back when we used to call them yardsticks? Yeah, I know. Meter sticks, and I would start here. Then I would ask the student to walk this here from this area. So here they are, taxiing on Charlie, and they're taxiing. Charlie's pretty long. They get here to Romeo Tango. They're going to take a left to Romeo Tango because they know that next is Romeo Alpha. Tango here, Romeo Alpha. Romeo Alpha falls right here. holding short of 26 left at Romeo Alpha. So you can start with these instructions relatively simple, then you can get complex with them. Now, in some cases, I have done this with students where they've done it with ForeFlight, and we've done it with iPads for this, where they could actually get the taxi instructions, and then they could sort of draw on their airport diagram how to do this as well. Whatever the procedures you want them to learn, here's a great way for that to happen. The beautiful part about these exercises is the fact that you can get as creative as you can. In fact, if you let your students have some time to kind of think this through and to see some of the creative things that they come up with, that's solid gold, because that's the stuff that you're after. You're after movement, you're after procedure, you're after these things that you can do on the floor, do in the driveway, do on a playground, or do it on the sim then whenever you're able to get the kids in a sim. Now, in this particular visualization exercise, this one may be considered more for the advanced classes that you may be teaching. And by advanced, I mean your instrument courses. As your kids come up through the program and those students are ready for that next challenge, the instrument rating definitely should be on their horizon. So with that, again, there are a bunch of conceptual things that are at play in the instrument world, and one of those has to do with approach plates or approach charts. And so with that, we want to take a look at something here that I think you might enjoy. Once again, I will ask, any idea where we are? Anyone? I'll give you another hint. Yes, aloha. We are back in the islands. In this particular case, this particular island, this is Maui. Maui, P-H-O-G, here, Papa Hotel Oscar Golf, and this is the ILS approach to runway 2 on Maui, or the Lihue Airport. So with this, well, let's take a look around and let's see what we have drawn out here on the floor. So with this, of course, we have the telltale instrument arrow here as well. And we also have here our initial approach fixes that we have from a couple of different areas, different locations. We have Harpo over here, we have Keiki over here, and here we have camps. And so camps is here where we turn on our approach course of 024 degrees. This is where we begin then here on our final approach fix here at Tebbs. And we come gliding down the old slope right down here to a nice smooth landing on runway 2 here in Maui. So a couple of things here that I have the students do when they're putting this together. It's important, I think, for them to kind of understand the scale of it, so as close to the scale as we can that appear on the charts, the better off I think that they are. With these also understanding here where the waypoints are, what the waypoints actually mean. The FAA, cleverly enough, I think does a lot to try to localize the flavor of some of these approach fixes when you get close to a certain area of interest, like for instance Maui. Harpo, any idea where the Harpo name came from with that? Ever hear of someone named Oprah? Well, if you look and you can you read this backwards, Harpo backwards is Oprah. Why do I bring Oprah into this? Well, because if you look over there to the north of Haleakala, which is that 10,000-foot volcano over here on the south side of the island, well, she basically owns all of that. So yeah, Oprah's kind of a big deal here. So it's kind of neat for the kids to understand some of the local flavor of this as well. When you looking here at the approach, understanding where your fixes are, also being able to label the DME here on your approaches. When you're looking here again, do you have any holds here? Do you have any procedure turns perhaps? Are there going to be procedure turns? Where aren't there going to be procedure turns? And make sure they label them out. Understanding here that we're trying to do this as close to scale as we can, but also know Keiki about 4.4 out here from camps. Harpo about 5.1 here from camps. So to kind of understand that in terms of time, So if you're here at about 4.4 out and you're doing, let's say it's 120 knots here with that, you basically have about 2 minutes and 15 seconds to be ready here to start your inbound course here and to pick up your localizer. So let's say, for instance, that I ask the students to say, okay, you're somewhere over here northwest of the island. Let's say you're coming in here from Molokai or perhaps Lanai, and you're going to set your approach up in, let's say, a G1000. Well, if you start that approach with that G1000, then again, you can start with your GPS here as well, which is noted by this magenta tape in the floor. So you can start your GPS coming in here into Keiki. And then from Keiki, you can also turn your GPS to make your turn here toward camps. But at some point, we're going to need to get our localizer dialed in and get that ready to go to intercept our localizer to begin our approach, right? So with that, most of the localizers there, especially in a G1000, when you set that up, it's going to be green. So with that, we're going to be looking here for our green line all the way to victory, right down here at the threshold of the 1,000-foot markers here at runway 2. Now, what we have done here is just set up the plan view of this particular approach plate. I did not do the profile view for this particular approach, but I think it's also important to include that when you have students doing these visualization exercises like this, because again, you want them to know as much about these approach plates as possible. So laying out all of your minima on there too. How low can you go? And so that's kind of one of the big things that you want them to understand. So as we look here, we can see that in addition here to some of the terrain markings that we've made here, and by the way, a big shout out to Ryan here in our shop who does all of our decal work on all of the equipment going out here of our shop here in Austin. Ryan has been such a huge help to me on putting these things together. So I just, again, a big shout out to Ryan. So buddy, you're aces in my book. So here you can see we've put kind of the terrain intervals in here, some of the topography that we've put into place here. We have marked our waypoints on the way down here in our approach. You can also see that we have begun our mist. So you can see the published mist. But let's just say that you're here on the island and you're actually practicing, you're practicing an approach like this. What would they actually have you do? Would they have you fly the mist out here, fly the actual published hold, come back in and maybe fly this all the way back to camps, do the procedure turn, come back in and start the approach? Probably not. But what they probably will do is they will send you out and they will give you a verbal here for vectors. And so they will give you vectors indicated here by the orange line, and the vectors coming back out here, probably sending you somewhere here just outside of Tebs, probably not all the way back to camps, you know, depending upon traffic and, you know, weather, etc. So they may bring you back here somewhere short of Tebs, put you back in here on the 45 to come back here and to intercept your localizer on the way back in. And that may be a way for you to kind of show students this is what you might expect here when we're out here practicing this, is to say this is kind of what they may do. They may do something a little bit different, but it's sort of illustrative of how they will actually practice this. Explain to students why they'll put you here on, in essence, a downwind leg, a base, and that turn in here in kind of that 45 degree to final with that. And that's kind of a way that, you know, they can kind of draw that correlation between a traffic pattern and what they may do here vectors wise, and explain why they put you on a 45 here as you pick this up. 45 degree angle. Number one, when you're hand flying it, it's a lot easier to turn 45 degrees than it is 90 degrees because you got a lot of stuff going on, but also that autopilot that's in that airplane, it's a lot easier on that autopilot to make a 45 degree turn than it is to ask it to make a 90 on some of the autopilots that are out there. So this gets you set up. Also, the terminology. What is it that you can expect ATC to be telling you at the various stages here? What about your altitudes? Who are you talking to when you're talking to ATC? So there's a lot of things here that you can do as you move the student around the board, if you will, as you move them around the chart, and to say, okay, start over here. Now, at what point over here are we talking to whom? What are we saying? And it's a great exercise for them to truly understand what happens here on the big picture quite literally the big picture. So, with that, this gives you an idea of some of the things that you can do here, even in the instrument world with your students, and hopefully this type of thing makes sense and gives you a place to start and expand and make these even better for your students. Well, there you go. I hope that you have enjoyed seeing a few of these exercises that I've used in the past, and hopefully you may want to use them in your classrooms, or perhaps you may have some others that you have used, or maybe even been inspired to think of different ways that you can use these exercises. If you have any questions, always you can let me know. You can email me at Redbird Flight Simulations and let me know your thoughts or your other ideas, and I'll make sure that we can share them with the educational group that we have at Redbird as well. So there you go. Thanks for your time today, and blue skies.